You know what bounces more than a bouncy house? Your suspension. And if it's bouncing wrong, you're gonna feel like you're riding a mechanical bull through a minefield. I would know. Don't ask how. Welcome back to the garage, people. And today, we're talking suspension. And I can already hear Derek typing. But what about the roll center geometry? Shut up, Derek. We'll get there. Maybe. Probably not. I'm doing this my way. Trust me. It'll be fun. Okay, so imagine you're driving and there's a bump. Without suspension, that bump goes directly from the road to your spine. Every pothole is a chiropractor visit. Every speed bump is a lawsuit waiting to happen. The suspension is the system that connects your wheels to your chassis while allowing vertical movement. It keeps your tires on the ground. It keeps your fillings in your teeth. It's the difference between driving and being in a paint mixer. The suspension has two jobs. One, keep the tires touching the road so you can steer and not die. Two, isolate the cabin from bumps so you can drink your overpriced coffee without wearing it. And the crazy thing is, these goals are at war with each other. I mean, you want soft springs for comfort, but soft springs mean the car wallows around corners like a drunk walrus. You want stiff springs for handling, but stiff springs turns your kidneys into jelly. Yeah, it's insane. And engineers have been fighting this battle since the 1800s, and they've come up with like 40 different ways to do it, but we're only covering the main ones, the ones that matter, the ones Derek will argue about in the comments because Derek has no life. With that said, let's get science-y up in this garage. Suspension uses springs and dampers. The spring stores energy, the damper dissipates it. Together, they're like a married couple. One does the work, the other one complains about it. To understand, we have to look at Hooke's law, which says F equals kx. Force equals spring constant times displacement. Basically, a stiffer spring, higher K value, more force for the same compression. This is why race cars feel like riding a jackhammer. High spring rates, no mercy, pure violence. But springs alone are chaos. Springs want to oscillate. You hit a bump, the spring compresses, then rebounds, then compresses again, bouncing forever. Like my hopes and dreams when it comes to driving F1. That's where dampers come in. Shock absorbers. They're hydraulic cylinders filled with oil. When they compress or extend, oil is forced through tiny holes. This creates resistance, friction, heat. The energy from the bump gets converted to thermal energy and dissipates into the air, like my motivation on Monday mornings. The relationship between spring rate and damping coefficient determines how your suspension behaves. Too little damping, bouncy castle. Too much damping, brick wagon. You usually want critical damping or slightly under. That's the sweet spot. That's the money zone. Now let's talk about it. The McPherson strut is everywhere. Every cheap car, every normal car, probably your car, unless you're fancy, which you're not. But what is it and how does it work? Well, the spring and damper in this suspension are combined into one unit, the strut. This strut mounts to the wheel hub at the bottom and the chassis at the top. There's a lower control arm that controls lateral movement, and that's it. Simple, effective, boring. But why is it everywhere? Well, it's cheap, has fewer parts, takes less space, and is easy to manufacture. It's the chicken nugget of suspension. Not fancy, but it gets the job done, and everyone's got it. The downside, however, is that geometry changes aren't ideal. As the wheel moves up and down, the camber changes a lot more than other designs. This is why your economy car's tires wear unevenly and your mechanic looks at you with pity. Also, the strut has to handle suspension loads and steering loads. It's doing two jobs. It's the overachiever at the office who burns out by 35 and starts a podcast about cryptocurrency. We've all seen it happen. But here's the thing. For normal driving, it's fine. It works. Millions of cars use it. You're not racing. You're going to Costco. The McPherson strut will get you there. It won't complain. It won't ask for a raise. It's the unsung hero of mediocrity. But what if you wanted more? Now we're talking about performance. The double wishbone suspension, also called double A-arm, also called expensive. This system has two control arms, upper and lower. Both are shaped like wishbones, or the letter A, depending on if you're British or American. These arms connect the wheel hub to the chassis. The spring and damper are separate, usually mounted between the lower arm and the chassis. But why is this better? The simple answer is geometry control. With two arms, you can precisely control how the wheel moves through its travel. Camber change, minimized, roll center height, adjustable, scrub radius. We can talk about it without Derek interrupting. This is the suspension on race cars, sports cars, cars that cost more than my annual therapy budget, which is considerable after that fateful Thursday in October. The downside, however, is space. It takes up room, width, height, and cost. More parts, more joints, more bushings, more things to wear out and make clunking noises that haunt your dreams. But the performance? Mwah. Chef's kiss. The wheel stays perpendicular to the road through corners. This means more grip, better handling. You can actually use that horsepower without spinning into a ditch like a chump. Formula One cars, double wishbone. Your Civic, McPherson strut, know your place. But what if I told you it gets even crazier? Multi-link suspension is what happens when engineers have too much budget and not enough supervision. It's a double wishbone on steroids. Instead of two arms, you get four or five, sometimes more. Each link controls a specific aspect of wheel movement. It's like having a personal assistant for every task. One link for camber, one for toe, one for lateral location, one for your existential dread. But why do this? Well, much like your ex with your phone, ultimate control. You can tune everything independently. Comfort, dial it in. Handling, dial it in. Ride height, dial it in. Your therapy sessions? Still need those, but at least your car handles well. Mercedes uses this. BMW uses this. Cars that come with a manual thicker than the Bible. You need an engineering degree to understand the suspension geometry. Or you can just drive it and pretend you understand while nodding sagely at the dealership. The downside is obvious. Complexity, more parts, more failure points, more money when something breaks. And something will break because this is automotive engineering and we can't have nice things. But I'll admit it, when properly set up, multi-link suspension is sublime. It's butter, it's clouds, it's what your back wishes all suspension felt like. Oh boy, here we go. The solid axle, the prehistoric suspension. This suspension is the equivalent of hitting someone with a rock to cure their headache. Both wheels are connected by a solid beam. One wheel hits a bump, the other wheel feels it. It's the buddy system, except your buddy's trying to kill you. Solid axles come in two flavors, live axle and dead axle. Live axle means the axle contains the differential and drives the wheels. Dead axle means it just holds the wheels and does nothing else, like me at family gatherings. Why would anyone use this? Strength, simplicity, cost. It's impossible to break. You can drive over boulders, jump sand dunes, do terrible things to your vehicle. The solid axle doesn't care. It's built different. Jeep uses solid axles. Trucks use them. Off-road vehicles. Anything that needs to survive the apocalypse or a particularly aggressive Walmart parking lot. The downside? Ride quality. When one wheel hits a bump, the whole axle tilts. Your other wheel loses contact with the ground. You're bouncing around like a tennis ball in a dryer. Handling on pavement? Terrible. You feel every texture, every crack, every choice you've ever made that led you to buying a vehicle with solid axles. But in the dirt, solid axles are king. Maximum articulation. Both wheels stay on the ground over obstacles. It's the difference between climbing a rock and crying about it. Air suspension replaces metal springs with airbags, not the safety kind, the balloon kind, rubber bags inflated with compressed air. The computer controls air pressure in each bag. More air, stiffer suspension. Less air, softer suspension. You can adjust the ride height on the fly. Driving on a highway, lower the car for aerodynamics. Hit rough roads, raise it. Need to load groceries? Drop it down. This is luxury. Range Rovers have it, Cadillacs, Mercedes S-Class, cars where the seats cost more than my first car. The advantages are obvious. Adjustability, comfort. You can have both handling and ride quality by changing modes. Sport mode, firm up the bags. Comfort mode, soften them. Valet mode, lower the car so the parking attendant can't take it off-roading. The downside, reliability, or lack thereof. Air springs leak, compressors fail, valves stick, is complex, electronic, expensive defects. Have you ever priced out air suspension repairs? It's cheaper to just buy a horse. When it does work, amazing. When it doesn't, you're driving a lowrider whether you want to or not. I've seen Audis stuck in pothole mode, scraping over speed bumps, the owner's souls slowly leaving their bodies. It's beautiful and tragic. Active suspension is wild. Forget passive damping. This system actively pushes the wheels up and down using hydraulic actuators or electric motors. The computer reads the road ahead using cameras or sensors. It calculates, it predicts. Before you hit the bump, the suspension extends to absorb it. You feel nothing. It's witchcraft. It's technology. It's expensive. McLaren has this. Some Mercedes, Formula One cars had it until they banned it because it was too good and made racing boring. Typical. The system can eliminate body roll completely. Pitch? Gone. Dive during braking? Doesn't exist. It's like driving on rails, except the rails are invisible and made of computer code. Why doesn't everyone have this? Money, cost, complexity, power consumption, weight. The actuators are heavy. The computers are complex. The engineers need therapy after designing it, which I can relate to. But hopefully in the future we get active suspension everywhere. Self-driving cars will need it. If the car's driving itself, might as well make it comfy. Your anonymous Uber will glide over potholes while you scroll TikTok and ignore the world. Progress! Quick science tangent, because I'm contractually obligated to blow your mind. Unsprung mass is everything that moves with the wheel. The wheel, tire, brake, hub, control arms. This mass is not supported by the suspension springs. Why does this matter? Inertia. Heavier unsprung mass means the wheel can't respond quickly to bumps. It has more momentum. It wants to keep moving. This reduces grip, comfort, control. Everything bad. This is why race cars use carbon fiber wheels, lightweight calipers. Every gram matters. Reducing unsprung mass improves everything. It's the cheat code. Your stock car has heavy wheels because they're cheap. Cheap means heavy. Heavy means bad, but you're not racing. So who cares? Drive to work, pay your taxes, contemplate your mortality. Your car will drive just fine. So after all this, the question is, which suspension is best? Trick question. There is no best, only compromises. McPherson strut, cheap, space efficient, good enough. Double wishbone, performance, control, expensive. Multi-link, ultimate tuning, complex, money pit, solid axle, tough, simple, rides like a wooden cart. Air suspension, comfortable, adjustable, brakes eventually. Active suspension, perfect, futuristic, costs your firstborn. Just pick your poison. Choose your suffering. Every suspension type solves a different problem for a different use case. Daily driver, McPherson is fine. Stop being dramatic. Sports car, double wishbone or multi-link. Feel the difference. Off-roading, solid axle. B1 with the rattling. Luxury car, air or active. Pretend you're floating. The important thing is maintenance. Change your dampers. Check your bushings. Worn suspension is dangerous. It's the difference between controlled motion and that fateful Thursday in October when my suspension failed and I learned what the word lawsuit really means. Here's the thing. Suspension is invisible until it's not. You don't think about it. You don't notice it until something breaks. Then suddenly every bump is personal. Every pothole is an attack. You're hyper aware that you're piloting a 2-ton metal box on 4 contact patches the size of your hand. It's terrifying. It's real. It's physics. Good suspension is transparent. It does its job quietly, keeps you safe, keeps you comfortable, lets you believe for a moment that maybe the world isn't so rough. Maybe things will smooth out until they don't. So, next time you hit a pothole and barely feel it, thank your suspension. Thank the engineers. Thank the springs and dampers working in harmony to protect your spine from the cruel reality of infrastructure underfunding. And to everyone in the comments about to tell me I forgot about torsion beam suspension or leaf springs or hydro-pneumatic suspension, I didn't forget. I'm ignoring them. This video is about the main types, the relevant ones, the ones that matter to people who aren't Derek. But I would love to hear what you have to say in the comments. And while you're at it, why not hit the like button and the subscribe button so we can keep getting sciencey up in this garage. Until next time, stay suspended. Watch where you're going.